Today we are going to talk about equations in two variables. So far we have talked about equations in one variable, meaning that our equations that we are solving for only have one variable that we need to solve for. Remember that solving means that we're finding unknown value. Today we are moving on to equation in two variables, which means there are going to be two variables in each of our equations. These variables have a relationship with each other in that one depends on the other. For example, whatever we decide to plug in for x will determine what our y is. Okay, so again here, y is depending on what x is. We cannot figure out what y is until we know what x is. Because we have two variables, that means that our solution of an equation in two variables is an ordered pair that will make our equation true. Remember that our ordered pairs are always written x, y. So we can check ourselves by saying, okay, 5 substitutes in for x and 35 substitutes in for y. If we substitute 5 here, 7 times 5 does in fact equal 35. So that would make our equation true. You must remember that the ordered pair is written x, y, and flipping around the numbers and putting the 35 here and the 5 here will be incorrect. All right, so to tell whether the ordered pair is a solution of the equation, we go ahead and simply substitute in. So I'm going to rewrite my first equation here. We've got y equals 2x. So now I need to substitute in, remembering that my first is my x value and my second one is my y. So I substitute in. I've got 2. That's being multiplied with our x, which is 3. And we're checking to see if it equals 6. So we don't know yet. So now we simplify it out. 6 equals 2 times 3 is 6. So yep, 6 does in fact equal 6, making our equation true. So we substituted in. We made sure to put the x substituted in for x, y substituted in for y. Simplified it all out. They do equal each other. This number sentence is a true statement. So we've got this ordered pair does make it true. Let's try a second one here. Again, we are going to rewrite our equation. Remembering that my first value is my x value, my second one is my y, and I substitute in. So in place of y, I've got a 12. 4 stays the same. It multiplies with x, which is 4, and then 3 minus 3. So once again, I'm trying to determine if this will be true. 12 equals 4 times 4 is 16 minus 3, simplifying it all the way out, telling me that 12 equals 13. That is false. 12 does not equal 13, making this a false statement. So once again, you're plugging in your x and y values to see if they will make it true. You must remember which one's your x, which one's your y, and to put them in the appropriate spot. Now, since this one was false, if I was looking to find a true statement, I could go ahead and play with my numbers, come up with a different ordered pair or pull a different ordered pair, and plug it in to find a true statement. That's all.